Okay, so again, we'll be looking at sine and cosine ratios, but we'll be looking at complementary angles today. Okay, so let's get these fish out of our way. Go swim away, fish. Okie dokie. Quick reminder. SOHCAHTOA. Right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, on the previous lesson, I briefly mentioned that, hey, look, the sine of S was the same as the cosine of R. Hey, look, the cosine of S is the same as the sine of R. And then I said, if you want to know why, stay tuned for the next lesson. Well, here we are. It's the next lesson. Let's see what's going on. Of course, in a right triangle, well, any triangle, we have to add up to 180 degrees. But of course, in a right triangle, that means the other two angles have to add up to 90. Now remember, if two angles add up to 90 degrees, we say that they are complementary angles. Right? So angle R and angle S are complementary angles. And there's a neat thing that happens with complementary angles regarding sine and cosine. The sine of an acute angle is equal to the cosine of its complement. Right? That's not a coincidence. It has to happen. The cosine of an acute angle is equal to the sine of its complement. Right? That's why it was happening. So if we've got a triangle, usually we just call it triangle ABC. If C is the right angle, that means A and B will be the complementary angles. And so if I start out with sine, I know that the cosine of the complementary angle will have the same value. So sine of A has to be equal to cosine of B. Or if I start with sine of B, that has to be equal to cosine of A. Same is true if I start out with cosine. If I start out with cosine of A, that has to have the same value as the sine of B. If I start out with the cosine of B, that has to have the same value as the sine of A. Okay, so let's check and see if this really works. All right, 30 and 60 are complementary angles. So let's see, does the sine of 30 degrees really equal the cosine of 60 degrees? Again, if I ever have a question in trigonometry and there's no diagram, I've got to get a picture. Boy, they sure had that cow stand still for a long time to pose for that drawing, huh? So let's get a triangle up here. In fact, it is one of our friends. It is the 30, 60, 90 triangle, which means we can use 1 for the short leg, root 3 for the long leg, and 2 for the hypotenuse. Now, of course, sine is opposite over hypotenuse. So sine of 30 degrees has to be 1/2. Cosine, of course, is adjacent over hypotenuse. So cosine of 60 degrees has to be 1/2. Sure enough, sine of 30 degrees really is equal to the cosine of 60 degrees. Okay, so I'm going to give you a bunch of expressions that are originally written in terms of sine, and we want to write them in terms of cosine. So sine of 40 degrees. If I want to use the cosine function, what would be the equivalent? That's right, cosine of 50 degrees. That's because if I have 90 degrees and I subtract 40 degrees, I'm left over with 50 degrees, right? 40 degrees and 50 degrees are complementary angles. What if I start out with a sine of 73 degrees? If I want it in terms of cosine, what would be the equivalent expression? Cosine of 17. Again, because those numbers add up to 90. Okay, let's go the opposite way. I'll start out with cosine, and let's rewrite this in terms of sine. Cosine of 27 degrees. That has the same value as the sine of 63 degrees. If we start with cosine of 48 degrees, that will be the same as the sine of 42 degrees. Right? Some of you might say, oh yeah, 48 plus 42 adds up to 90. Or you might say, nah, I'll grab a calculator, do 90, take away 48. Oh, hey, 42 left over. So it looks like today we have an... come on, let's try this better here. Come on. Okay, so today we have third time's the charm worksheet. Yeah, if you look at the IXL for this section, you'll notice I'm not assigning very many IXLs. We just have not gotten far enough into detail with all the neat bells and whistles. I mean, yeah, there are some IXLs that seem to have the right title, but if you clicked on them, you'll quickly discover that so far we've only talked about degrees, and a lot of times the IXLs go into both degrees and radians, or in some of them, even though we've talked about sine, cosine, tangent, the IXL uses all 6 trig functions and not just the 3 we've studied. So IXL is, well, we just haven't gotten very far in Algebra 2, right? We've been backtracking and doing a lot of first-year algebra to fill in some gaps, and so we just haven't quite gotten as far as we normally would have liked to have gone. So we're kind of just going to hang out with some worksheets on some of these assignments.